Okay, so let me share my screen.
Okay, now that the recording is going, we'll welcome you to the first session of day 2. Our friends from Intel have a presentation on their work with Ceph Mesos, and looks like the presentation is up and ready. So take it away whenever you're ready.
Okay, hi, my name is Zhongyue. I am in Intel Shanghai. I am going to introduce to you a Mesos framework that we have developed called Ceph Mesos. It is a Mesos framework to scale Ceph clusters on Apache Mesos. And I've developed this with my colleague Zhang Kun. Zhang Kun, do you want to say hi? Okay, guess he's gone to the yeah. Okay, so let's start. Okay, so let me get my laser pointer out. Okay, so I'm pretty sure that you all have heard of Apache Mesos, but just to be sure, I'll do a recap of what it is, and then I will introduce to you our proof of concept deployment of Mesos and explain why we needed Ceph in our Mesos deployment. And then I will introduce you to what Ceph Mesos, how it works, what our goals are, our scopes, and our current challenges and development goals. Okay, so Apache Mesos. So Apache Mesos is a distributed systems kernel. So what this means is that it is built in the same principles of the Linux kernel, but at a different level of abstraction. A Linux kernel manages a single Linux box, but Apache Mesos, a distributed systems kernel, like manages the whole data center. So what Apache Mesos does is it provides your applications with APIs to run on an entire data center. So these APIs are resource management and also binary scheduling. If you have any questions, jump in anytime. Okay, so the architecture of Apache Mesos is Apache Mesos consists of 3 components. First is the framework, and then there is the Apache Mesos master, and then the Mesos slave. The framework consists of a scheduler and a executor. So what happens in Apache Mesos is that these slaves periodically report their resources to the Mesos master. And then the Mesos master, if there's a framework, then the Mesos master also periodically sends resource offers to the framework. And if the framework needs resource to run their task, then they accept their offer. And then they send the task info and the required resources, and then the Mesos master redirects these task info to a slave and runs their task. How these tasks are run is by the framework sending their executor to the slave, and then the executor runs the task on a slave. Okay, so this is what I've talked about what Apache Mesos was, and in this slide, I will talk about what we are doing currently with Apache Mesos. So we are trying to build a big data platform as a service based on Mesos. So what the frameworks that we use in our POC is Myriad, which scales node managers, what Yarn nodes that is, and then there's HDFS Mesos, which scales HDFS cluster in Mesos, and then there's a thing called CDAP, which is the PaaS layer of our big data analytics platform, and then Marathon and Mesos DNS, and then we've added Ceph into our POC because we needed Ceph to run Ceph as a big data storage backend. alternative to HDFS Mesos. And I'm sure most of you know about the Rados Gateway file system that Joanne, my colleague, is developing. So we are trying to integrate the Rados Gateway file system the and Ceph into our POC. Okay, so our motivation is that we are trying to integrate Rados Gateway file system, which is a HCFS, Hadoop compatible file system, and then we are currently using Myriad to manage our node managers, and we want to guarantee data locality when we use Ceph as our storage backend for big data analytics. So we needed a framework to manage Ceph in the same cluster that we manage our node managers. And also, one of the things is that Apache Mesos is becoming an application deployment platform. When this project started at '09, it was only for like running Spark distributed workloads, but currently the Mesosphere DCOS, it installs Cassandra, MySQL, all of those long running services. So why not Ceph? So we thought that a deployment framework for Ceph will be also needed. So that is why we started this project. Okay, so our goals and scope is to implement a Mesos framework for Ceph, and we have already implemented. We have released the 0.0.1 version, um, and we will provide Rados service in a Mesos cluster, and our current main target is to support Rados Gateway, and the block device and file system will also be supported in future releases. So our scheduler will schedule Ceph binaries, and how these binaries will run on the slaves are in the Ceph on Docker containers. So the Docker container image that we use is the image provided by the Ceph organization, and also, configuration files will be downloaded from a static file server to share the configurations across the Ceph nodes. So the architecture is like this. In the very top, there is a Ceph Mesos scheduler, and there are 3 threads running inside it. There's a file server, there's a REST API, and then there's the callbacks implemented by the Mesos SDK. And then there is the Mesos master, slave, and our executor. So what happens is that once you run Ceph Mesos scheduler, it deploys a monitor. And then after the monitor is deployed, the configuration files that are in varlib Ceph are copied to this file server. And then if you want to scale a OSD node, then you send a flex up request to the REST API, and then by through IPC, this request goes to the callbacks, and then when Mesos master sends a resource offer, then the callback accepts the offer and then sends the task info to the Mesos slave through the Mesos master, and then the Mesos slave knows the URL of the file server and then downloads the Ceph Mesos executor from this file server, and also the configuration files from the file server, and then the executor launches OSDs or Rados gateways or other binaries like that. Okay, so our version is currently 0.0.1. Currently, we only can deploy one OSD in each host, but OSDs need to be run on multiple disks on a single host, and also the journal is best written on the SSD. Currently, we don't support these two features, but this feature is currently in development, so it will be implemented soon. Also, the data traffic, we want to make it go through the 10 GB or 40 GB network, and the NIC selection or the CIDR selection will also be implemented in the future. Also, we want to implement flex down, reconciliation. We also want to integrate Mac VLAN to our framework, and etc. Yes, and our source code is currently on GitHub. So if you're interested in Mesos, you can fetch the code and try it out yourself. Okay, that is the end of my presentation. Is there any questions?
Yeah, so you were talking about right now you're restricted. It's restricted to only one OSD per host.
Yeah.
And typically, like many deployments will end up sharing a single SSD for many different OSD journals. How do you envision implementing that with this framework? Because it looks like, without knowing too much about Mesos itself, it looks like it's running like one container that's kind of isolated for each OSD. So how will they be able to how are you going to implement like partitioning a journal SSD that's shared among different containers?
Well, the journal thing right now is that in the Docker container provided by the Ceph organization, it simulates a journal by creating a file inside the Docker container. So, well, I'm not that clear of how we are going to solve that problem, because the journal performance is very critical for production environments. But let me get you back to you after I talk with my colleagues over here.
Okay.
So
Yeah.
I have another question. This is Sam. Sorry. In the general case with Mesos, these applications that are running are usually stateless with respect to the local machine, right?
Yes, correct. Yeah.
Okay. The OSDs are super duper not stateless, right? There's a big fat disk full of big fat data, right? So how do you plan on control? So I guess there are two pieces. One, you can't rapidly expand and contract a Ceph cluster without really messing with client I/O. It might make sense to dynamically deploy and undeploy temporary Ceph clusters for working space for a job. Is that what you're looking for? Or are you talking about
Well,
dynamically
no,
expanding and contracting one big cluster?
No. Actually, we are not trying to. This framework is not for dynamic cluster Ceph clusters. It's actually just to unify the control plane of your data center. So yeah.
Okay.
So
So early in the
currently,
process.
Yeah. So currently you use you use Ceph deploy to deploy your Ceph cluster. But what we are trying to do is that if you already have Mesos in your data center, then why not just use Mesos to deploy your cluster rather than using Ceph deploy? Yeah.
So secondarily, does Mesos have a way of distinguishing host types? I very much doubt that you'd want to be running compute workloads on the same physical node as Ceph. For one thing, if you're using the file system, you risk. Well, if you're using any of the kernel KV, I guess you wouldn't be, so it wouldn't matter. But anyway, I doubt you'd want to do that. So does it have a way to make sure that A, the machine you're getting is appropriate for a Ceph node in the first place, B, that it's in the same network that you've already been asking for nodes in, and
yes.
all that exists?
So yeah. The Ceph slaves have a attribute called roles. So if you specify a role to a framework and a slave, then all the binaries for a typical framework can be only scheduled to those roles with the same to the slaves with the same role. So if you have a small cluster of hosts in your big Mesos cluster, which role is Ceph, and your Ceph Mesos framework also has a role called Ceph, then the framework can only schedule to those small set of slaves which have Ceph as its role.
Okay, that makes
So
sense.
yeah.
So another thing that comes to mind is it possible for Mesos to schedule like bringing up several monitors at once, rather than doing a single one first and then adding more later?
Yes, it is also correct. That is also possible. I haven't shown you an example of our REST API. So in our REST API, you can specify how many instances of a binary you want to expand. So let's say instance is 10 profile OSD, then that means you want to increase 10 OSDs. And also in this REST API, you can specify a particular rack or a particular host.
Okay.
So it's
So
very flexible. So
you could actually schedule, like, say, I want to start 3 monitors and put them in different racks.
yeah, that is also possible. Yeah.
Cool. Do you use the Amon initial members configuration option right now?
Well, currently the initially there's one monitor and 3 OSDs.
Mm-hmm.
Yeah, and then you can like flex up OSDs or flex up monitors.
Okay. Yeah, just an idea for the future might be being able to, instead of start with one monitor, start with 3, and have that set in the Amon initial members list. But at that point, you need to have the IPs of all of them before you can start up. So that might be problematic.
Yeah. So we will make it possible to like specify in the config file you want 3 initial monitors, and then when it spawns 3 monitors, it will first spawn the first and then copy the configure files to the second, and then the information will be merged to the file server. So yeah, the IPs will be shared eventually among the 3 monitors.
I see. Yeah, that makes sense. In terms of other clients, so how does the Radius gateway get set up then? Does it also just copy the ceph.conf from existing monitor nodes, or how does that work?
So the Rados gateway you're talking about, right?
Yeah.
The Rados gateway has a Docker image of itself. So yeah, the Docker pulls the Rados gateway image and then it executes the container.
Mm-hmm.
And the container has a way to inject some form of configuration, which it gets from the the framework,
The shared
right?
file system, right?
Yeah.
Well, via the
and
shared file system, but yeah, via the framework.
Yeah. I wanted to mention that when you launch the Docker containers, it directly mounts the varlib ceph of the host directory. So all the data and configuration files are persistent. It doesn't go away when the Docker container shuts down.
That's kind of odd though, because it means that the OSD-ness of the node outlives the Docker container, which of course it would have to. But is that intentional?
Yeah, it is intentional because you know a host might have a problem with the power. So if you reboot the host, you still want the data to be persistent on the same host, so
Yeah,
that
you do.
you can you just you just restart your container and you have your data over there. So
Makes sense.
Is there any like higher level automation for like assigning different labels and things to nodes in Mesos, or is it more of a manual step? Or
it's more of a manual process currently. Yeah.
are you aware of like projects that are trying to automate that step, or is that generally
Well, it might be a layering thing. That
administrative
might be a
defined?
Puppet or a Chef concept. Or with this,
Yeah. It may. It should
Could be.
be a Puppet, Ceph, or Ansible problem. Yeah.
so as it joins the Mesos cluster, it's also endowed with these attributes. Okay, that makes sense.
Hmm. Yeah.
So as you guys have been working on this, have you run into any bugs or issues with the Ceph Docker?
Well, currently we haven't
Yes.
done any, big scale testing. So yeah, currently, well, there is this one problem where you have a single host with multiple OSDs. That there's no problem with that. But if you have multiple hosts which have multiple OSDs inside, then the whole system goes crazy. And there are many reports on the web that say that they have the same experience, but currently we don't know what the problem is.
Sounds very
Sounds like
strange.
something wonky with. Is that with Docker or with Mesos? It sounds like something wonky with the Docker.
So
What do
with
you call
Docker,
it?
so
Networking.
even without Mesos, if you manually launch multiple OSCs on multiple hosts, then the monitors don't can't are just hangs in a certain.
It's probably because
Yeah.
the externally visible IP is different from the one they think they have. Yeah, that would
Oh,
definitely break
okay.
it. Pretty
Okay.
much, I don't think you'll be able to use Docker's network names, whatever the hell it does. The thing where it hides the host's networking details from the container, you'll have to disable that.
Okay. Yeah, that
I
is
don't
why
think you'd want
we're
it
trying.
anyway. It's not really valuable in this case.
Uh-huh.
Well, it's a little valuable. I just remembered that Docker relies on that to prevent you from accessing the hosts you'd have. Or no,
Oh,
other thing.
okay.
Anyway, it might be a security thing, but you might have to just choose to trust the OSD container.
Mm-hmm. Okay. I'll try that.
All right, I guess we're going to be way ahead of schedule here. Was that everything?
Yeah, that is about everything. Yeah.
All right, good deal.